I'm P.J. Udo, a mathematician. Of course, the highest degree I've obtained is a PhD. So that is what we have. This lecture series will take us into about 4 topics. Namely, we shall look at what we call functions. Then we have the limits, and of course, the differentiation. Next, we shall look at the integration. Also, we shall look at binomial expansions and theorems. We shall also look at the combinations, of course, with permutations. Then we shall study probability, and of course the theory of sets, and we relate all this and apply them to the business mathematics. Well, when we talk of a function as a start, so the first topic we want to discuss is the function. And we want to study what is meant by the function. We want to see the implications, and we want to see how are they related in the subsequent topics we want to treat. When we talk of a function in mathematics, is a rule that assigns elements in the domain to what we call the codomain. Take, for example, you have this. If this is A and this is B, if there are elements A, B, C, and D, and here you have 1, 2, 3, 4. If this is taken to this by what we called F. So what this implies is that F is a function that carries elements of A to elements of B. This A is called the domain, while B is called the codomain. Of course, this can also be called range. So the assignment or the rule that takes elements of A to elements of B is F, and that F is a function. Now, explicitly, if f of x equals to 2x plus 3, and we want to find, say, find f of 2, that means we are substituting the value of x equals to 2 in the given function. So any place we find x, we substitute 2. So this is equals to 2 times 2 plus 3. And that is equals to 7. So that function, when x is 2, gives 7. Now, we can also look at what we call the domain, which is this. And we said that when we look at domain, we can define this as a set of values of x, which the whole thing, the values of x can be assumed to be called a function in the domain if this value is finite. That is, the finite values of x in this particular set of values of x in the domain there. So we can also look at some examples in this regard. Of course, this notation, f of x, means f is a function of x. The function of x. Function of x. So you have g, f is a function of x, so g of x will mean g function of x. It's a function of x. So we define it as that permits us. Now we want to examine the next definition, or we want to take some examples to illustrate these functions. Now, if this function is given us, for example, we want to show that the question is determine the domain of the function, determine the domain of the function, and that function is given as f of x that takes to 3x minus 5 if r equals to minus 2 minus 5 and 4. When this r equals to minus 2, minus 5, and 4 is the range. That's the important word. Is the range of that value defined on D. So what we need to show is that this 3x is part of solution, that 3x minus 5 equals to 2, and if 3x minus 5 equals to 2, because 2 is the first number in the range, so we can evaluate the value of x here. This implies that 3x equals to minus 2 plus 5, which is 3. So if 3x equals to 3, therefore x is 1. So similarly, we do the same to 3x minus 5 is minus 5, which shows 3x equals to minus 5. We take this, 3x is 0, x is 0. Also, 3x minus 5 equals to 4. So 3x is 9, x is 3. So the question calls for that we should determine the domain. So the domain of the values will be, this is, if you like this is the first value is 1, the next one is 0, and the other one is 3. So this goes to the value of -2, -5, and 4. So the range or the domain equals to 1, 0, and 3. So that's how we can determine the domain of this function, having given the range. Now, subsequently, we can find the range as you're finding the domain. Now, closely related to this is what we called defined and undefined functions.